One of the biggest mysteries in science is dark matter. There is 5 times more dark matter in the universe than normal matter. We can't see it, but scientists have been looking for it for a long time. So, what is dark matter?
We don't understand truly what dark matter is. We kind of know a bit more about what it's not, to be honest. We know that it doesn't really interact very much with ordinary matter. And we know that there's quite a lot of it in the universe. And we've got lots of different sources of evidence that suggest that that's the case. So it's never ever been observed on Earth, which is something that experiments are trying to do to prove that it actually is there.
There are many experiments in the world looking for dark matter particles from space, including the Lux Zeppelin experiment.
Lux Zeppelin, my experiment, it's a direct dark matter detection experiment located in the Homestake mine in South Dakota, USA, using a technology that was pioneered here in the UK at the Boulby Underground Lab. So the detector is designed to look for dark matter particles bumping into our detector volume. Theoretically, it's all around us.
Every single time you basically move on to another generation, you increase the size of your experiment, basically. At the same time, you basically also have to improve the background. That's something that we're basically trying to do with a facility like CREF.
So we're working on the Cold Radon Emanation Facility, CREF. The problem is that we construct our detectors from materials. Those materials have within them some trace amount of uranium or thorium, and that in itself is a bit of a problem. It produces gamma rays, neutrons, but these are things that we can handle. Each time we get more and more sensitive, a new background pops up, something else that's now limiting our search or looking like dark matter. The most problematic one at the moment is radon.
Radon has a really long half-life and is chemically inert. And basically what this means is that it can emanate from detector materials to inside our active detector volume. The problem is when it continues to decay, you eventually reach problematic atoms. So like lead-214, which can mimic our background signal.
So the theory says that, well, as you cool down materials, the amount of diffusion that out of the material you'll get from radon will reduce. So actually we want to perform these tests at low temperature, and that's tricky. It's more than tricky, it's not really been done anywhere. It's certainly not been done at the sort of scales or sensitivity that we need to construct the next generation experiment.
The Cold Radon Emanation Facility at Rutherford Appleton Laboratory aims to improve our understanding of background radiation that mimics dark matter signals. This will make future experiments more sensitive. With a clearer understanding of each background, it becomes easier to see a true dark matter signal. CREF began commissioning earlier this year, and scientists are hoping to take measurements soon.
We've been working quite long and hard to reach this stage, so we've been setting things up already here at Rutherford Appleton Laboratory in our experimental hall. We get all the expertise from the other institutes also involved here, so it's really the community that's coming together here.